in this clip, we're going to be talking about a more precise way to describe what the area of a geometric figure is. So let's go ahead and talk about that. We're going to be answering what is area. So your teacher in 8th grade or something probably told you a couple of the formulas, like the area of a square or a rectangle or something, but they probably didn't tell you more precisely what it is, so I'm going to be trying to describe that in this video. So let's go ahead and write out a definition. So we can define area to be area is defined as the amount of square units worth of space that can fit inside of a closed 2D figure, or is referred to as surface area of 3D objects. So what do I mean by this? In order to describe what square units are talking about, let's figure out what it means to have 1 square unit. So if we draw a square here, we know that what defines a square is that it's a quadrilateral or a 4-sided figure with all of its interior angles are right angles, and we can draw the arrows here in order to indicate the 2 sets of opposite sides are parallel and these 2 are parallel, and then we draw another arrow over here in order to differentiate the opposite sides we're talking about, but also what makes a square unique rather than a rectangle or something is that all of the side lengths are actually equal, so we can use tick marks all around in order to show that. So we have 1 going all the way around, so 1 unit, because if it's a square, then there's only 1 possible way that we can have 1 square unit, and that's if we have all the lengths around it to be 1, because area is described as the length times the width for a figure like the area of a square. And also we know that the area of a square is often represented to be side length squared, because the length is 1 and the width is 1, and if you change the size of the square in any way, then the length and width would still have to be the same, so s squared. So in this case, we have 1 square units, or just 1 square unit, and that square unit can be whatever unit you want it to be. It could be square feet if they're both feet going around the perimeter. It can be square meters if it's meters. It can be anything. So but since we want to generalize it, we're just going to say square units. So let's say we have some kind of an oblong figure here, something that looks like this. Well, as long as it's a closed 2D figure, meaning that there's not a break in the boundary, then we probably can figure out a way to figure out what the area is using calculus or something to describe the figure and adding up the infinitesimally small pieces. And that's oftentimes how you learn eventually that it's possible to find the area exactly of what curved figures are. So, okay, so, and then it's basically like your answer would be how many of these square units can fit inside of a figure like that. So if you have a rectangle or something, then you're just gonna keep putting the square units in there for the whole thing until you have your area. And if you have a 3D object, like a cylinder, for example, then here, notice that the boundary is not just a one-dimensional line anymore, but the boundary is actually a two-dimensional surface all the way around the outside of the figure, and then we can find the volume on the inside, actually. So, yeah, see if I can fix the drawing here a little bit. Okay, so it's something like that. Okay, so this is generalized what area is, and we're going to do other videos on proving the other area formulas like the parallelogram, the rhombus, the trapezoid, all of that, and I can prove those formulas, but now you know in a generalized way how to describe the area of figures. So hopefully you found this helpful, and come back in the next one where Joe shows you how.